Okay, so welcome to our talk, Serverless AI.
Also called What Could Possibly Go Wrong?
I have the clicker, so if Mike starts rambling, I'm going to just go next slide, and we'll see if we can control him for the next 30 minutes.
Is the clicker connected to me?
Yes, your clicker. You ready? Speaking of which.
Okay, I'm fine.
So, Serverless Minecraft.
Is that what we're doing?
This is a talk about Serverless Minecraft. Well, no, it's not. No, it's a talk about building applications using GenAI.
Thankfully, a whole bunch of people haven't left. So are we doing it about blockchain?
No, Mike. I told you before, it's a talk about building an application with generative AI.
Shout out to Alex for making the obvious point to us before we came in that we needed to have this slide. This slide got added 20 seconds ago.
Correct. Tip to any budding speakers out there, if you put block in your title, some people will think blockchain.
Okay. Oh no, this talks about generative AI.
Yes.
Shut the doors, yes. Don't let people leave. Okay, yes, we're talking about generative AI, but we're talking about an important part of sort of a new wave of application development with generative AI.
Indeed we are, indeed we are. And we might have a demo at the end.
Yes. We're talking about building agents.
Agents? Is that like James Bond?
A lot like secret agents. So in the context of generative AI, an agent is an application, a piece of code that can take a non-deterministic input, do something with it, and then cause a non-deterministic output. It's kind of like the panacea?
The panacea is the correct word, Mike.
Software development.
Well done.
Yes.
And so this is what you typically think of when you're building the panacea, which are agents, where on the left-hand side, you'll have some users interacting via chat. And let's face it, most Gen AI apps we see out there is a chatbot. Boring.
Not more chatbots.
So this is not a chatbot. Also some unstructured data, so a website or crawling that into the agent in the middle, which will be interacting with a lot of tools on the right-hand side, data sources, API services to get more data. And then up the top, we have the LLM. Now, the important part of this diagram is the little arrow at the bottom. Nope. Which is telling the agent that it can apply what it's learned to itself, which is very, very important.
This diagram's boring, Derek.
It is, Mike.
Let's make it more interesting. So we're going to be using Minecraft as the client for this particular demonstration application.
Yes.
So we're not going to be making chatbots.
Who's played Minecraft in the audience? Anybody? We have a few Minecrafters.
Woo.
Excellent.
Notable exceptions. We have seen who you are.
We have an axe. And then, speaking of axes,
tools, yes.
We have the tools that our agent will use to interact with Minecraft. We will have the bot itself.
The bot.
Lovely. It's not smiling at the minute, but hopefully we'll get it to smile later on.
What can we do about the large language model? What symbol should we use to show the large language model?
I have no idea. Sounds a bit like magic.
It's totally magic. Yeah. That's what large language models are.
They are, absolutely.
For the purposes of this discussion, anyway. And yes, and those arrows that Derek was talking about before, really, really important. So the bot can actually use, to have a conversation with itself and actually reason amongst itself with what it's going to do with these tools, and the tools will end up influencing what happens inside of Minecraft.
They will, if it works.
So, and then we are going to be able to go, if it works.
That's the phrase of Gen AI, if it works.
Yes, yeah. So, and then we are going to be able to play alongside. So we want to have this bot inside of the Minecraft game. We want to be in there too, and we want to play alongside. So.
Sounds like fun.
It sounds like fun. Now, the tools that are available are. If you've got the clicker, then you've got to press are very, very simple. And so this is part of the demonstration here, is that in order for the agent to do the things that we're going to ask it to do, we're only giving it access to fairly simple tools. So jump.
I'm not going to jump.
move to a position, locate a player. There are others in there as well, like dig a hole, that kind of stuff. So we'll ask it to do more complex things than just that, but these are the tools that it's got to work with. So bear with us. This might not seem like the most incredibly intuitive playmate inside of Minecraft, but it's a lot of fun.
It's a lot of fun.
It's a lot of fun. So let's have a look at what it actually looks like in the game. Now, these are a couple of pre-recorded demos, and you'll see why when we get to the end, but we'll definitely do some live stuff. If we ask it hello, then it doesn't need to use a tool. It can go to the agent, it can go and use the large language model, it can respond, and it can say hello. And it's usually pretty friendly and happy because of the way that we've prompt engineered it. Next up, jumping.
I'm getting there.
Yes. So if we ask it to jump, and we've gone too far. Okay, so we've asked it to jump, then it will jump, but it's only going to be used. Hey, I've got a back.
This is the clicker. Okay, I should never be given a clicker.
God, who gave him the clicker? Please, come on.
There we go.
So so if we ask the bot to jump, then it will basically do a one-to-one mapping with the actual tool, which is to jump. So nothing very exciting there. We could do that with some string matching, right? There's nothing too amazing about that. This is the much more interesting one, honest. So come to me. There is no tool which is come to me. So if we ask the bot this, then it actually has to reason through a set of tasks that it could do with the tools available. The first one will be to find out where I am, so it can do that. And then the next one will be to move from their current location to where I am. So this is showing just a really simple version of it, reasoning through how things work. And yes.
Do a lot more than that.
You can do so much more than that.
And we will demo that
sometimes
later.
And we will demonstrate that coming up.
Okay, so that is the concept of the game. That's the concept of agents. So how did we build this and what was the architecture? So a lot of you played Minecraft before. So Minecraft runs on a server. So the architecture could be lots of servers.
Whoa. Sorry.
What?
Sorry, guys.
What?
You just mentioned servers.
Servers. Oh, all right.
That's an EC2 icon right there.
That is an EC2 icon.
I'm so sorry.
Right,
Please do apologize. Can we do something which isn't server?
Well, we could do this. So we could move it onto ECS Fargate.
Oh, Fargate's serverless?
Yeah.
We're okay with that?
We have 3 elements.
A little bit. No.
Oh my goodness.
Definite no's there.
Tough audience. So Minecraft agent and LLM. Okay. Let's move the LLM into SageMaker.
There's a Lambda function
Amazon SageMaker, and then Lambda in the middle, which we can run as the agent.
Just bear with me 1 second. I just want to look out there. We said SageMaker. That's okay, right? No, I don't think they're okay with SageMaker.
But I'm using LangChain and my Lambda agent, and that's serverless.
LangChain is good. Serverless, Lambda is good. But can we go better than this?
Okay.
Can we go
There we go. So we can combine the Lambda and Amazon SageMaker into agents for Amazon Bedrock, which is serverless.
Yes.
And then on the left-hand side, we have the Minecraft server, which you can run on a container and get from GitHub. Yep. And you can run a very thin client to maintain state. Now, you could potentially run the client on Lambda, but then every session would be 15 minutes long. Yeah,
so we have some things that we want to maintain state, we would need to be up for a while. So the server, and we're not going to get into how we could do anything other than running it in the Docker container. What we really want to talk about here is agents for Amazon Bedrock. So this is capable of doing all of the agentic workflow, and agentic apparently is a word, and we can do all of that stuff that we do in LangChain inside that Lambda function with this. So let me show you a little bit about how this works. Now, I'm going to stand here and pretend that I'm typing, but I recorded this as well. We will do some live stuff. And I wanted to show you how easy it is to make an agent inside of AWS. So inside of Amazon Bedrock, that's the service that allows you to get access to generative AI. We can go and actually build the agent inside of the console. This changed kind of recently. So if you've seen it like a few months ago, it's definitely better now. So we can connect up the agent to the model that we want to use. Here I'm using Claude 3 Haiku. And then we actually get to put some instructions in. So this is actually part of the prompt templating for this agent. So this is kind of important. This is super simple. We're going to create a bot that can help the large language model tell the time. So if you've used large language models plain out of the box, they have no idea what the time is because they're just large language models. So if we type in here, what is the time, we get our answer back that we're sorry, we don't know. So this is the plain large language model happening. This is Haiku. At least it's not hallucinating. But because we're inside of an agent, we get the ability to give it tools, so that's what we're going to do now. So we create an action group. We give the action group a name, and I thought I'd clipped out this so it was faster, but hey. As we scroll down, we've got a couple of different ways that we can create these action groups. So we can actually have the console here create a Lambda function for us, and I know I said Lambda-less, we'll get to that, but create a Lambda function for us which will actually respond when the agent is making this call. So we're going to create a getTime action group function, and we're going to give it that description, which is super important for the prompting that we do. We could add parameters, but we don't need to in this particular case. It's going to be really, really simple. Now, when we press create here, it actually makes a Lambda function for us and actually does all of the heavy lifting of the permissions stuff in the background for us as well. You can deploy all of this with CloudFormation. We'll have a look at that too.
You can.
This is the Lambda function which has been created for us. And in the event that comes into the Lambda function, we've got this function, and that's going to be saying to this Lambda function what function is being called inside of the action group. And so I'm just quickly pasting in some code here which is going to return the time in the time zone that Lambda runs in, so how useful that's in, I don't know. So we just deploy that, and with that deployed, we can go back into the console, and we can prepare our bot, because our bot's sort of sat there waiting with the agent group that we had. So once we've prepared it, if you've seen workflows in, is it like Lex and Alexa, it's a similar kind of thing. And so now we say, what time is it? And hooray, it knows the time because it's able to go and use that tool to get the time. Super, super simple, but the same concept of what we're using in order to play Minecraft, which is much more difficult and sometimes works.
Okay, well, let's see how this thing works.
Yes, absolutely. Well, should we take a look at some code?
Oh, code, yeah, absolutely, now we're talking. So, as Mike mentioned earlier, we can define everything as code that we're going to show you today. So what we've got here is the agent code, first of all. Do you want to show the top level where we do the check of the action?
Yes, absolutely.
So in here, if you scroll down.
Can you see that?
No. If you zoom in, control.
How's that?
Control plus it. Yep.
Bit more? Or you're right?
Yep. Bit more.
Bit more?
One more. So what we're doing, and Mike forgot to mention Mindflare. So we're using Mindflare, which is an open source bot framework for Minecraft. And Mindflare expects some actions. So if that's imported, if you scroll down, you'll see all the actions that we know about.
So here we go.
There. Yes. So we've got action dig,
time, jump,
reading, and every one of those maps to a function. So if we then go to one of the functions, maybe one of the more complex ones?
Yeah, so we've got this one here, which is the action to dig. So one of the things that we should mention here is that I did say how there were different ways to be able to create the integration between the agent and some running code. In the last demonstration that we looked at, it created a Lambda function for us, which was the target, the destination for what the agent will call. What we're doing here, and if you remember back to our previous diagram, is we have that tiny little container, it's tiny, in Fargate, which is serverless, which sits right next to the, which sits right next to the Minecraft server itself.
Yes.
Yeah, and so what's happening in there is that we want the code to run on there. And so we're going to use return control style of the agent workflow. So when we make the call to the agent, it actually responds to us with the function definition to call and the parameters to send to it. So if you're familiar with function calling inside of some of the other models, then it's very similar to that, but it's fully managed inside of the platform.
Yep, and the final piece of code we're going to show is a CloudFormation template that provisions all of our things. Oh, actually, just scroll down and show people Like it's not that complex. It's not like 1,000 lines. It's quite straightforward. And then the CloudFormation template, because there's no magic here. This is not ClickOps.
There is magic. We saw it before.
Yeah, and apart from the LLM, there's no magic. So the CloudFormation template looks like that. So it is actually infrastructure as code for your Bedrock agents. Okay, so that is the code. Can we start running this?
We can try. Do we have to? Yes, we
What could possibly go wrong?
Okay.
So this is a live demo of GenAI Minecraft bot. Thank you very much.
Yes. Right, I just need to remember what to type
what we need to do, we need to start the bot and attach it to a running Minecraft server. So that's what Mike is doing now.
Yes.
We've got our bot spawned.
So it's spawned, so if we go over to Minecraft.
Into our already running Minecraft server,
look,
we
it's
see
there.
Rocky.
It's there. And look, guess what? It's night time. So I'm going to set the time. No, can you see it? Not really. I'm going to set the time. First of all, I'm going to say hello to the bot so that you can see that it's there. Rocky, Amazon Bedrock, there's our bot, and it's responding to us.
And Rocky is very, very friendly, by the way, waving excitedly, very happy to see us.
Yes.
Which can get tedious after a while, but hey.
These logs that we've got here are quite verbose, so bear with me as I scroll through stuff. But you can see here that my player name has said hello. It's got a bunch of stuff, and essentially the bot's just coming straight back with a text generation. It's very, very straightforward and simple. No tool was required here. So I'm going to say here, I'm going to set the time. This is now me Minecraft hacking. Yep, this is not what I intended to do. This is not a bot command.
This is a direct Minecraft aficionados out there will know this command.
So when I do this, most likely the bot will come back to us and say, I can't do that because it thinks that I'm asking it. And so it says, I don't have the ability. It's fine. Sorry, Rocky. Sorry to get in your way. OK. What should we do first?
We found this bug this morning, and we didn't filter it out.
Yes, we tried.
Full disclosure.
Yes. Yes, amongst lots of other things we were trying to get this bot to do.
OK, how about the dig? We haven't seen a dig yet, Mike.
We haven't seen a dig yet. OK, so we can ask it to do that. So if I say, hello, please dig a hole. And so obviously using natural language, I'm not just saying dig, and there we go.
Yay, go Rocky!
Well, there we go. Yeah. We've got it digging a hole. Now, this hole technically is kind of round. It's kind of mapping it out in the code behind the scenes. And so it's making it go even deeper. It's a little bit nervous about going into the hole because if it digs too deep in a flat world, then it actually ends up going through to nowhere. So there we go. If we come back over here, and I'm probably going to be typing this a lot. So I'm going to say, come here, please.
So, interestingly enough, so we're also using another open source library, Pathfinder, which is a plugin to Mindflayer.
Yes.
So we found that that's quite an interesting library in itself. Some quirks to it.
Why is my head getting wet? It's a question that I've got, and I really want to know the answer to this. And so, again, hopefully it says, it looks like it's raining. And so,
genius.
So the bot has access to a tool, which is it raining? But it's mapped the fact that I think my head's getting wet to the fact that maybe it's raining, so maybe I'll check. So it's making those decisions on the fly. Obviously, we just did a come to me, which was more complex as well. Just before we leave digging holes, because I like digging holes.
We've dug a lot of holes, by the way. Over the last week, we've dug a lot of holes.
So we can say dig a small 2x2 hole. And we'll have a look at what actually it passes out from here. Now, the 2x2 is 2 in diameter and 2 depth before you look at it and say, well, hopefully it digs it. And so this is a way that we can actually pass parameters onto the model. So in theory, that's a 2, but that looks way deeper.
It's a much smaller hole. Let's get smaller like that.
It seems to think that it's done that. So if we go back over to the code over here, then see if I can just scroll up here. There's a bunch of debug stuff, and here's the bits that we want to have a look at. So I said here, can we dig a 2x2 hole? And it has passed through that. And this is the return control data set object blah thing that it came back with, which is asking our code that called it in the first place to call the action dig and to dig a hole of 2 by 2. So it's actually looked at what we've asked it to do in natural language, parsed that apart, pulled out the parameters, and said, cool, here, go and do that. So I think that's super cool, even without having to do multiple different actions inside of what it needs to do.
Very interesting. Okay, what about finding stuff, Mike?
Yes.
Let's find some wildlife.
Stuff, yes. Okay. Well, I'm just going to ask it to come here just to make sure that it can get out of the hole. And you notice that sometimes it digs its way out of holes, which is kind of fun.
Nothing wrong with that.
I think they know enough about things to just reset things at this point. So it is actually maintaining a chat conversation here as well. So the agents from Amazon Bedrock, which is a service we're using behind the scenes, remember, is also maintaining this state. So we could ask it about things. Conversations can go on for a very long time, and things can get confusing after a while. So let's see if we can see anything around here.
Is that a bird? I saw a bird.
Let's not do birds, 'cause they don't stay on the ground. I think there's some pigs over there. So can you find, can you, keep it simple, Mike.
This is live.
Pig.
GenAI demo, serverless.
Let's go there. Why am I doing two things at once? Okay, so I don't want it to just to find a pig, because it might just say, yeah, I know where one is, and give me the coordinates of it. Oh, here we go. Wow, I'm just going to fly, if that's okay, because it's a bit easier. Oh, look, there's a pig right there. Hey. Excellent. And this time, it didn't destroy the fence to get in there.
It actually jumped over the fence?
It actually jumped over the fence. And it's also told us the location of it. The villagers getting super excited.
Very excited.
Because of
hey,
what's
Rocky!
Hey! And the cat's coming over.
Let's move on from that.
Well, let's. Shall we do the thing? Shall we do the thing?
Do the thing. Let's build stuff.
We took this to the Singapore Summit a week and a half ago. A different version of the code. It was way better now. And all that people wanted to do was attack and kill. So we'll do that.
And
so
build and kill.
So we do attack the pig, because it's right there. So yeah, you can see that attack the pig. Yay! I don't know if that's something you should clap for, but I probably would. Okay. All right, so let's leave that. Let's see if we can. All the villagers are very interested in the fact that we've attacked stuff. Okay.
How about we get out of the pen and
we're going to come over.
Maybe build
The villager has a house over here. So let's say come here. We should probably be looking at the code sometimes as well, but you know what the code's doing, it's fine. We managed, we've broken out, we've probably destroyed the fence, now all the animals are going to disappear, that's fine. Let's have a look to see if we can do some collection, shall we?
Oh,
shall we try to do some collection?
We need to collect to build.
Yes. I need to press the T button. Yep. I need some logs. Can you collect some? See how this goes. So far, my spelling seems to be right. Yes, and we're destroying the house. Yes. And we're collecting a bunch of logs, because the easiest place to get the logs is from the house, which we kind of knew that would happen, right? So that's awesome. Hey, what are you doing behind there?
Stuck.
Hey, come on, there you go. Sometimes Pathfinder gets stuck behind things, but that's oh, you having another go? All right.
More logs. More logs needed.
Keep going. Why not? And so, again, using the Pathfinder library to use a collection and try and collect. How many logs do
you need?
Well, I didn't specify. I could have specified, and then it would have said.
Yep.
And so it says that it's collected 10 logs. I'm not sure. It seems like it might have collected a few more than that to me, and left that house entirely unsustainable. So there you go. Come here.
If anybody's ever demoed GenAI Live, they've no idea what can happen, because anything can happen.
Yes.
So it's very interesting.
Can happen. Okay, all right. Any suggestions about what we ask it to do?
Anybody? Shout out.
You are here. We can see you.
Build something. Build something.
Oh, what could possibly go wrong? Okay, so the bot even knows this, but the build code is experimental. If you thought that wasn't, this definitely is. And one of the things it really struggles with is building over the top of other things. So I'm just going to ask it to come away. We're going to go somewhere a bit separate. Come on, Rocky. Let's go. Another thing, I found it quite difficult in Singapore when people were being a little bit mean to Rocky.
Yes. If you put this in the hands of real people without any supervision,
who haven't,
bad things happen. Like, call me fearless leader bot.
don't have this deep empathy that I have.
All sorts.
Reset, probably a good idea. Okay, all right, what should we try and build? I don't know what. So pardon? Shelter. A shelter, that seems very tame, but okay, yes.
I haven't tried that.
No, let's not say that. Let's build a shelter, please.
Pretty, please.
So what's actually happening here? I explained the architecture before, and we didn't sort of talk about anything quite this much. What kind of shelter?
A small hut, please.
a small shelter. Okay, so the reason why that happened is inside of Agents, Parameters, and Bedrock, as part of the, I'm going to press enter. Okay. The reason why that happens is inside when you're actually setting up the agent, you actually have a setting in there which can allow the agent to come back to you to ask follow-up questions. So there is prompt engineering around the hole digging to say, look, if we don't ask you, just choose your own size of a hole. But if you turn it off, if you turn that part of it off, it will always say, well, how big of a hole do you want me to build, et cetera, et cetera. Let me get out the way. Look, it's a perfect shelter.
Look at that.
It likes building things that you can't fit inside.
There is a gap there for the rain.
Oh yeah, there's a gap. We could stand in there.
Yep.
I'm not sure it's going to shelter us from the rain very much. But that's awesome.
Show the code for the...
Yes. Yep. Okay. I was just going to tell them about the code.
No,
I could show them the code. Right. Let me go back here. Okay, so the way this works is that actually uses double Gen AI. So if you thought that single Gen AI was amazing, what we use here is an action called action build. And what this does is it actually goes away itself and uses another large language model to try and figure out how to build something. And so here is the prompt that we use for that. And so this is a prompt that's been set up. We have some code that's capable of building more or less if we provide it with a data structure that looks a bit like this. So, and word wrapping is not working here, but you can see basically it says, you are tasked with designing creations in Minecraft. If I say view word wrap, is that how you do it? Yeah, there you go. And so we want you to basically create this output for us. And this is a sample of the kind of output we want. It's not actually going to look like this, and I don't know what that character is doing there. But generative AI, it doesn't care. Yep. And so we've got the rest of it here, and we've got some examples of some blocks you want it to use. One of the things about this template structure is it actually obviously inserts in here the thing that we want it to build. And if we look in the code, you'll find that it translates, shelter in that case, and puts it in here. And then we do a couple of other things. So we actually give the model room to think. This is quite a common practice when using large language models, is that if you just ask a large language model to immediately come back with an answer, then that answer might not be great. So giving it room to think and say think between some thinking tags can be really helpful. We go one step further and say once you've done that thinking, then read your thinking, review it, and make sure you're okay with it, and then come back with your output. And we specify somewhere to bring the output back between output tags. And so this is essentially the kinds of things that LangChain will do. We're just doing it ourselves with code. And we were having a conversation before about how if you really want to extract all of the value from the model you're using, just write your own prompts. It's kind of fun, and it's not that hard to do. So that's the prompt which runs, and it comes back with the list of things and how to build the certain thing. And if we look here, then we can see our shelter is here. That's the shelter that it came back with. Let's build something else.
Okay.
It hasn't gone horribly wrong yet, so we can keep going. Okay, let's set the time, and we'll come back over here and see if we can build something else. Okay, you fill in while I'm typing time. Time, set, day. Okay, cool. And then let's do a come to me. Unfortunately, when we do this, the pathfinding sometimes destroys the things it's standing on. It hadn't finished the fact that we'd changed the time. Okay. Now I'm going to reset and say, come to me. You can get a bit of a control complex by working with this bot. Come on. Here we go. Okay, cool. I didn't destroy the house either, which was pretty
Well, thank goodness, because that was quite a useful...
It was an amazing house.
Yep.
It was an amazing house.
Okay.
Yes.
Let's go. Last build, and then...
Okay, yes. All right.
Yep.
What are we going to build? Something a little bit more extravagant that I can spell. What, sorry?
Eiffel Tower.
Yeah.
Go on, do it.
Aeroplane, did you say? Okay. Okay. How do you spell Eiffel? I said something like a spell. Okay.
E-I-F-F-E-L.
Build a small E-I-F-L-E.
No, E-I-F-F-E-L.
E-F.
E-I. Yeah.
Yes!
Yes.
That was the best answer. Build a small Eiffel Tower. Okay, let's see what happens. And so that's why when it says, let me see, basically what's happening is it's going and doing that generation. And because we're actually generating quite a lot of text with all of that prompt, with the thinking and the reviewing and then the output and stuff, it takes a little while to do. It's using Sonnet, by the way, behind the scenes to do this. So reasonably powered large language model. At some point, we'll get it working with...
Oh, it's a dog.
Watch out for the cat!
Oh, no.
Okay. Okay, let's start building. Okay, here we go. It looks like the Eiffel Tower to me. Yay! Oh,
Hey, it's great. Yay!
Oh my!
There's four columns.
Oh, okay. That's my building code.
Perfect.
So
Okay.
I think it's
Very good. Very
okay.
good. Hopefully there's nobody French in the audience. I apologize.
We won't destroy it and come back later. Okay, so hey, where do we go from here?
Well, let's leave some feedback, a feedback form.
Yes.
So if you've enjoyed this talk, we'd like you all to fill in the feedback form, which you'll see via a QR code that we're slowly flying to now.
And obviously, we'll be hanging around here as well. So if you'd like to come and muck around with us a little bit more, see a little bit more about how it works behind the scenes, then please feel free.
We're also doing a live stream tomorrow from 10 a.m.
I'll be there.
3-hour live stream
12
on...
a.m.?
12 a.m. Midday.
I thought you said 10. Right, okay. Yeah.
Midday.
Yes.
Tomorrow on LinkedIn. Native
How many
LinkedIn
hours will
channel.
that be?
3 hours, Mike.
hours?
You and I
Oh,
and
okay.
Brooke for 3 hours. Yay!
Yes. We basically need 3 hours to get this working really well, right? Okay.
Yes. So that's the QR code. Thanks very much. Please fill it in. Give us feedback. Come have a chat. And hopefully we'll have this code published on a friendly GitHub repo in the very near future.
Yes.
Thank you.
Thank you very much.
Thank you, Derek and Mike.